Okay, we are ready to start now. Hello, everyone. I'm Takehiro Michikawa, an assistant professor at Tokyo University, Japan. It is a great honor to be able to speak to you today. My presentation is entitled Air Pollution Research Among School Children in Japan. Conflict of interest. I have no relevant financial relationship to disclose. My affiliation, Tokyo University, is located near Haneda International Airport. Nature, Life, Man, the founding spirit of Tokyo University is the title of a book by co-founder Susumu Nukada, whose educational principles have provided the distinctive ethos to the development of the university, which is focused on natural sciences. At this university, I teach environmental health. My research focuses on the health effects of air pollution, mainly ambient air pollution. This slide shows the ambient air quality standards in Japan. In Japan, particulate matter, or PM, has been regulated as suspended particulate matter, was SPM, since 1972. Suspended particulate matter is defined as particles that pass through a size-selective inlet with a 100% cutoff level of 10 micrometer in aerodynamic diameter. So, SPM is equivalent to PM with an aerodynamic diameter of less than 7 micrometer. The particle size of SPM ranges from PM 2.5 to PM 10, so SPM includes not only fine particle but also coarse particle. The Japanese air quality standard for PM 2.5 was established in 2009, after which routine measurement of PM 2.5 began at ambient air pollution monitoring stations. Here, you can see annual average concentrations of PM 2.5 in 47 prefectures. As you can see, the PM 2.5 concentrations in the eastern region are lower than in the western region, and the national average is approximately 30 micrograms per cubic meter. Today, I'd like to discuss two Japanese studies that examine the association between long-term exposure to air pollutants, mainly PM 2.5, and respiratory health in school children. The first focused on the association between traffic-related air pollution exposure and the onset of asthma, while the second investigated the association between exposure to PM 2.5 and lung development. The recent Integrated Science Assessment for Particulate Matter by U.S. Environmental Protection Agency concluded that long-term PM 2.5 exposure is likely to be causally associated with respiratory health problems. It didn't conclude that there was a causal association between PM 2.5 and respiratory health. Therefore, we need more evidence of this association. I'd like to first talk about traffic-related air pollution exposures and respiratory health. A study designed for the school children cohort in the study of respiratory diseases and automobile exhaust project, namely SOLAR project. Sora means sky in Japanese. Many studies have examined the association between traffic density and asthma prevalence, but studies assessing asthma incidence are limited. In the present study, we wanted to know is whether exposure to traffic-related air pollutants is a risk factor for the onset of asthma or other respiratory illnesses in Japanese children. Specifically, we conducted a school-based prospective cohort study to elucidate the prospective association between traffic-related air pollution and the incidence of asthma. Here, you can see the study regions. The participants were recruited in 2005. Of the 57 total schools, 49 were located in school districts, which included one or more of the pre-selected heavy traffic roads. The other 8 schools were not located in such heavy traffic districts, but were located in the same administrative district as at least one of the 49 schools. The participants were first to third grade students, 6 to 9 years old. As surrogates for long-term traffic-related air pollution, we used the annual average concentrations of automobile exhaust originating nitrogen oxides and elemental carbon. These concentrations were estimated using a time-place summation model. First, the average annual outdoor concentrations for the houses and schools of all the participants were estimated using the dispersion model. Then, the indoor concentrations in houses and schools were estimated based on the outdoor concentrations. We then determined the total amount of time each child spent at home, school, and outdoors over a typical school day, 24-hour period via questionnaire, and multiplied these 24-hour values by the above indoor and outdoor concentrations, respectively. The overall calculation was defined as the individual exposure for each child. Follow-up surveys were conducted annually for 4 years after the baseline study. We used modified Japanese version of ATS DLD 78C to determine the incidence of asthma. This slide shows the main findings of the solar projects. Figure 1 on the left shows longitudinal data of the estimated average concentration of nitrogen oxides and elemental carbon in the outdoor areas around the participants' houses and schools, stratified by zone based on the distance from heavy traffic roads. Both nitrogen oxides and elemental carbon concentrations showed a decreasing trend. As you can see in figure 2, the odds ratio per 0.1 microgram per cubic meter increase in elemental carbon concentrations was 1.07, a statistically significant result. In sum, we found that traffic-related air pollution was associated with the development of asthma in school children. I'll now discuss the second study, which began in 2011. The aim of this study was to explore the association between long-term exposure to PM2.5 and the growth in lung function over a 7-year period from 9 to 15 years old. We selected 10 areas throughout Japan: Sapporo, Sendai, Sakata, Tabashi, Shibuya, Nagano, Matsumoto, Okayama, Fukuoka, and Amami. We recruited 130 third grade, that is 9-year-old children from one or more elementary schools in each area, for a total of roughly 1,300 children in the study. Following the manual continuous monitoring of ambient air pollution, we measured the concentration of PM2.5 and its components, as well as ozone and nitrogen dioxide. The PM components included organic carbon, elemental carbon, nitrate, sulfide, ammonium, chloride, sodium, potassium, calcium, and magnesium. Measuring equipment was set up at each elementary school. This slide shows the monthly average concentrations of PM2.5 during the study period, measured at each elementary school. The PM2.5 concentrations tended to be higher in spring than in other seasons. An outcome assessment was performed at the same time each year, and the pulmonary function data was obtained by trained staffs. We analyzed 3 indicators of pulmonary function: forced vital capacity, FVC, forced expiratory volume in the first second, FEV1, and flow at 50% of vital capacity, V50. A baseline questionnaire completed by each child's parents or legal guardian was used to collect information on the children's characteristics, including past history of respiratory or allergic disease, anthropometry, passive smoking, dwelling conscience, presence of pets, physical activity, and so on. The questionnaires, including the International Study of Asthma and Allergies in Childhood Questionnaire, which were administered at the time of the annual pulmonary function testing, were used to update information on respiratory symptoms. This slide shows the relationship between age and FEV1 and FVC, respectively. Naturally, both FEV1 and FVC increased in step with age. The data collection for the study was now being completed, and we will soon be able to report on the association between long-term exposure to PM2.5 and the growth in lung function. This then concludes my talk on past Japanese studies that examine the pulmonary health effects of air pollutants in school children. As you know, perinatal exposure to air pollutants has been adversely associated with fetal growth and development, such as reduced birth weight, preterm birth, and congenital anomalies. Here is a brief summary of the results of our previous study. We explored whether maternal exposure to air pollutants was associated with small for gestational age, which was defined as birth weight below the 10th percentile for gestational age. In this study, we found a robust association between other exposure over the first trimester and being small for gestational age. Now, let's move on to talking about our future plan. This is a last slide. Past studies focused on exposure during childhood and examined the association between exposure and respiratory growth and development. However, the effects of perinatal exposure of air pollutants, namely exposure in utero, may persist from the fetal stage into childhood and even adolescence. To better protect child's health, then we should elucidate the sensitivity window for exposure to air pollutants. Thank you for your attention.